Thank you, everyone. Can you hear me? So today I'm going to talk about our Triatek solution, which is the environmental control for healthcare. Let me start out with the agenda. So the first one, I'm going to talk about the critical environment solution for Johnson Control, just some fundamentals, right? Then we'll go over the product overview, which is the Venturi valve. Then we talk about why we do use Venturi valve versus VAV. So that's Venturi valve versus VAV. Then we also talk about application for healthcare. Then we'll talk about environmental control BMS, which plays a very, very important role as part of the total solution. And we have the controls and monitors. So let's go to the slide. So in terms of critical solution for controls, it's a global company, as you know. We have more than 30 years of experience designing and manufacturing innovative airflow system for critical environment. Again, for healthcare itself, right? Largest portfolio solution industry that I'll show you in a few slides that's coming up. And extensive experience of course, building that kind of adds on to it, right? Because when you look at environmental control, we have the full set of solution, but more of a muscle. Where we bring in the total control part, is where the BMS comes in. So a bit of history of Triatek, right? It was founded in 1985. Right? I'm not sure you guys are aware of Triatek, right? So in 2018, right, Johnson Controls bought over. So Triatek, we will look at them, the specialty is on the healthcare environment. So they have full sets of solutions. Basically, we look at here the displays, the Triatek displays that you can see in the hospitals. Then you have the Venturi valve, which we're going to talk about, where the critical thing that we're going to talk about for how the whole solution fits in, right? Then we have FlowSafe, which is the fume hood. Right? Sometimes we use it in the hospital, sometimes in the wet chemistry lab, or even the pharma. So that's the solution. So in 2018, we acquired, and so the last 4 years, there's a lot of changes. We actually kind of fully integrated, and we have actually new solutions where we buy integrated with our Johnson Controls product itself. So before, if you look at the topic, right, it talks about airflow. Of course, we talk about Triatek. The reason because is that if you look at critical environmental, it's always about airflow, right? It's how the flow of airflow itself. So if you look at the fundamental, there's 3 pillars for Triatek solution or Johnson Control solution. Number 1, safety, right? When it comes to environmental control, it's all about safety. Number 2 is reliability. And third thing is efficiency. When you talk about safety, our products are fast. We need to be fast. As we talk more later part, you'll understand why quick response is very important, right? Faster response time, right? And in terms of reliability, right? In terms of because you're talking about healthcare, right? You have something on top, you're not going to open up and fix it, right? So it's very important to have a reliable solution. So that's something that we're going to talk about, and of course the efficiency. We talk about net zero and all this stuff, right? Because we look at healthcare, one of the big fundamental things is about, especially you have healthcare environment we talk about operation. Surgical rooms or even OT rooms and isolation rooms, there's a lot of air exchange needed. So when you talk about air exchange, there's a lot of, you're bringing in outside air, so a lot of energy consumption. So fundamentally, there's a lot of energy saving to it. If you look at types of critical environment, you have operation suites, isolation room, clean rooms, emergency rooms, oncology. Then as you go sideways, pharmacies, right? Even indoor government facilities, right, where they have healthcare plus also pharma in build, K-12, especially like learning university, healthcare for that, bio-contaminating facilities, and of course there the wet chemistry where we have the fume hood controls and also crime labs. So because it's, when you talk about critical, it's always about airflow, right? So I'm going to talk some fundamental because then it's easier for you to understand how Venturi comes, right? So if you look at any building, like even any, let's say, occupied floor, fundamental, we have supply and also exhaust, where you're coming in and exhaust it out, right? There's 3 kind of rooms. So one is basically neutral, right? Especially you look at hospital, typical patient room, right? It has its positive, it's neutral. And when it comes to the next one, let's see. Then you have directional flow of positive pressure, where if you look at positive, the supply is more than the exhaust. That's what you see, the supply is more. So you call it a positive pressure, right? Typically, example, in a hospital, you look at OT rooms are positive pressures because we don't want the germs to go out, right? I mean, that's the whole idea, the whole fundamental of it. Then on the opposite side is the negative pressure, where more exhaust than supply. I think so with the COVID, we have seen a lot of isolation rooms where people are isolated for COVID. You don't want the germs to come in to all the areas. So that's where you find there's more exhaust. So this is called a negative pressure. These are very fundamental. Then we're going to talk a bit about the strategy, because again, that's kind of ties back how the Venturi valve solutions comes in together, right? So there's three control types. One is the common one is the volumetric offset, basically the CFM differentiation. We talked about supply and exhaust, right? So it's about, usually it says 100 CFM or 200 CFM. So that's one control portion of it, all right? Look at example, the supply is 1000 CFM, exhaust, so it's about, the difference is about 100 CFM. Then you have a pressure differential. That's very common, right, in a hospital environment for critical environments, right? So typically you have 0.01. That's the difference that you need to maintain, right, to be positive or negative pressure, or 2.5 pascals, right? And the other one is volumetric offset with pressure and override. This is typically used for a fume heat application, hardly, not much on the normal hospital environment. Now let's go into the product overview. So these are the solutions that we have as part of the Triatek solution of Johnson Controls. On your left is the Venturi air valves, which plays a very, very important in the environmental control, right? Right below is the FMS, because these are the muscles of it, and these are the controls part of it, because you just can't work as standalone. So if customers want a standalone mode, we have the FMS. We'll go into details part of the solutions, right? As you know, since we bought Triatek in 2018, right? So we also integrated our Merasis, integrated fully with the Merasis. We have a new CCM controllers, right, and with the display. And of course, we have sensors, accessories, and we also have for fume solutions, the sensors and also the fume flow controls also. So let's talk about Venturi valve. So this is typically a design of the Venturi valve. It's pressure independent, usually it's pressure independent, and it's totally different from a VAV box. If you see a VAV box, you have a blade open and closed. But it's conical solutions. If you look at it, the design part of it, it has an actuator, it has a shaft, and it has a cone. So this is fundamentally how Venturi valve looks like, right? So as I mentioned earlier, we have the actuator, we have the shaft, the cone that moves up and down, right? So this is, the actuator is where it's controlled by the controllers, be it on the CCM or from the standalone controllers. So that kind of triggers, let's say you want 100 CFM or 1000 CFM, that controls that, and that moves it. And this one, the cone moves and up, so the airflow comes in. So if you look at the fundamental control, it's all about two things. One is the control of CFM and also the pressure difference, right? So you look at the design itself, 50. As it goes, as it needs more airflow, it opens, the shaft goes in, right? It goes outside. So this is where the airflow comes in. That's how the fundamental. So if you look at it, right, the shaft moves, this cone moves up and down. This is the fundamental. That's one way of how the control is done. As for the flow control. Now, this is where the criticality part, right? The pressure independence. So whenever someone is opening door, let's say you're operating a room, the nurses are opening a door, you still have to maintain a positive or negative, right? Be it in the OT room or in the isolation room, and see how it works, right? The shaft remains as say, but the cone moves. So how fundamentally is that, if you look at the cone, you break it down, there is a spring inside, so basically it compresses or decompresses. That's how it works. So when the pressure builds up, it compresses internally, right, so that it absorbs the pressure. But the pressure difference is always maintained, because you need to maintain about 0.01 inch water column or 2.5 Pascal. That's how fundamental how it works. And if you look at, I talked about, one of the critical thing about is the safety is number one, right? And reliability is number two, right? So in terms of how our design is, because if you look at the picture, we actually have a factory where every single Venturi valve is fully tested. So let's assume that, you have a customer wants or consultants, let's say you have a purchase order and you have an order for, let's say, 100 or 200 Venturi valves. Each and every Venturi valves have to be tested, because it's a critical environment, right? You need to make sure the right flow is there. You need to make sure that with variations in the pressure is still maintained. So that's why we have, we have a good manufacturing processes where testing is done, calibration is done. There's a lot of calibration is done. You can't have any error, especially you're talking about healthcare. So that's where we have all the testing and everything is done as part of the solution we provide. And this is how, you can see this is how where we test it. We actually have the venturi valve and we look at the flow, right? Because one thing that you'll find, I didn't mention that the venturi valve, right, it does not have any sensors, right? You can ask, right, how does it maintain 200 or 300 or 400 CFM, right? It's mechanically calibrated at the factories. So it's like 42 readings, like each 100, 200, 300, 400. Each one is calibrated, so it's mechanically calibrated. And there's a reason why, right? You have to make sure it's mechanical. You don't want to, when you have VAV, there's a lot of challenge, which I'm going to talk about it later. So we're going to talk about why venturi valve, because we have seen some sites, where customers has asked for VAV boxes, but our Johnson Controls recommendation is always go for venturi because it's proven, right? And that's what you should be using for environmental control, especially for OT and critical areas. Right? It's highly accurate flow metering device utilizing a dynamic cone assembly, as I've shown you earlier. Right? Accurately control airflow, even at very low velocity pressure. Again, it's fully tested, right? It's fully calibrated. High turn down ratio up to 20:1. What does it mean? It means that performance of even when you open the cone a little bit, right? The flow of flow of the air is constant. It doesn't open up. If you look at a VAV, right? You just open 5%. There's a lot of gush. 30% of the air starts coming in the first 5 to 10%. So that's why the turn down ratio is very good, 20:1. For VAV, it's 3:1. Right? That's how the turnaround. Designed to provide accurate and repeatable flow and pressure control specifically for life safety spaces. So this is fundamental, right? Especially for hospital environment. And it's maintenance free because why? There is no sensors. We don't have flow sensors, like VAV boxes, you have holes there, it kind of looks at the static pressure, then you get a CFM, right? There's no sensors at all, right? That's why it's maintenance free, right? And I was told that, typically you don't have to do any maintenance, which is not good for service teams. But typically 10 to 15 years, right? You don't have to. Only thing that you need to check yearly is to make sure that fundamentally the control logics are working fine. Right? So, what are the issues with the VAV box? Again, this is some customers ask for VAV box, but we don't recommend. But these are some of the challenges. If you look, the first one is the time delay problem for critical. Because if you look at critical, right? If someone is opening the door, closing the door, or the nurse is coming in, or someone bringing some stuff. You still need to maintain the positive pressure, right? Or even for, let's say, isolation room, you need to keep a negative pressure. You don't want the germs to go out, especially for isolation room, right? So this is very, very good. So if you're using the VAV box, it takes time to settle down, right? It's okay to use for normal offices, but when it comes to hospital environment, you need to make sure that, the time delay, it can't work with the time. It has to be responded within less than 2 seconds. That's what we need. For VAV boxes, it takes time longer, right? Then the other one is sensors can easily become blocked, causing incorrect airflow. That's quite common. But you don't see that in office buildings, right? But you will see that in a hospital environment. Why? Because again, imagine you are in an OT room, right? You need to clean the bed sheets, right? You need to put it clean. It might be happening 4 or 5 times. There's a lot of cotton. It all sucks up, right? Fundamentally, what's going to happen? It's going to block the airflow. Well, what happens when blocks the airflow? You won't have the right control at all, right? You might be sending in more airflow. Your loop is going to go haywire. You're not able to maintain the CFM and also the pressure. So these are the fundamental problems, right? So that's why we say our venturi valves are maintenance free. Must be cleaned often, resulting in higher maintenance and recalibration costs. That's very, very fundamental. Right? But let's think about it, right? If you look at the OT, right, you won't have time for people to come in and maintain, right? Especially when it's peak time and all this stuff. So that's one of the things. You have VAV box, you need to plan for at least every 6 months. And you have to go there upstairs, open up, and you have to have man code. But usually the OT rooms are very small, or 600 square feet, or even less than that, right? So that's one of the big challenges. Then strict guidelines on protocols for cleaning, right? Again, we need to have a time and all those stuff, right? And it's not precise control, right? Especially when it comes to rapid changes. Because what I mean by rapid changes? So like, as I was saying, like opening door, or someone opens the toilet door, right? So you need to respond very fast. So these are some of the challenges that's faced by using the V and cannot effectively control directional airflow. So that's one of the biggest challenges. I think so it's okay to use for normal consulting offices for healthcare, but not for critical operation areas or critical areas. Then come back to the design difference, right? As I was saying, right, look at the flow. This is VAV boxes, and you can see this is the airflow, right? So it takes in the differential pressure, right? It changes the velocity, and you have the CFM. So that's why it needs to have a regular cleaning, right? When the sensor is blocked, the controls will open and damper to compensate and increase the flow. That's quite fundamental, right? Because one is blocked, it thinks there's not enough airflow. So the supply opens, exhaust works, opens, and the supply opens, as more AI will come in. So you don't have a right control at all. That's one of the biggest challenges that we have. But look at venturi valve, right? There's no sensors at all. There's no sensor. You won't find any. As I said, it's mechanically calibrated, right? Every venturi valve that comes out or you order is always calibrated. Even one, each single one is calibrated, right? When a flow changes, it's required actuator moves the linkage. As I was showing earlier, right? One is fundamental, is the shaft that moves. The other one is basically when the pressure difference, you can see there is a spring over there. That's how it adjusts the pressure difference, right? If it goes up, it still maintains the flow. You have a 200 or 300 CFM, it maintains. It does not change. It's 0.5 degrees, right? CFM. And it's maintenance free, right? As you see, there's no way for the cotton or anything to get stuck. So it's lifetime, right? I would say 10 to 15 years is quite a long time for less maintenance. That's the fundamental part of why venturi is preferred. Sorry. So coming back to summary, right? Again, venturi air valve, safer, faster, more accurate response, right? Efficient control, maintenance-free. Solution for occupied and unoccupied modes. Again, I forgot to mention this, right? So one of the fundamentals, we always talk about net zero, how to reduce energy, right? So when you're not using, let's say OT, let's say about 30 minutes or 40 minutes, right? With venturi valve, you can switch it off, or you can go to unoccupied mode. And when you kind of put it to occupied mode, it goes back to the control very, very fast. But if you're using VAV box, it takes time, 30 to 40 minutes. And what happens is that most of the places where they use the VAV boxes, they'll just keep it on. Imagine, right? You have like 10 or 15 OT rooms, a big hospital, there's a lot of energy saving that can be conserved. Then as in VAV, more appropriate non-critical spaces, flow process can become easily clogged, can strain HVAC system and increases energy. Again, remember this is connected to your VAV boxes, AHUs. Again, that is going to increase your energy, then it's going to hit your chillers. So it's all connected, right? And issues of controlling negative, positive pressure, which is fundamental. And the other part is that, it's inlet sensitivity. The way how you install it, because when you look at, you're trying to install a flow meter, you need a special, certain diameters maybe. For VAV boxes, you need at least 7 to 10, I think so 10 times the diameter, right? But with venturi valves, you can put on a very tight, the way, because again it's small, right? You can put it on even look for the fume hood, it's very tight. Again, when we test it, when the customer tells us, it's very tight, we actually test it. We actually test it in vertical, horizontal, all these things are done. So that's why it's fully calibrated. When it comes, it's going to work 100%. So let's look at the applications, right? So you look on your left, that's the more of an operation theater, right? You can see a venturi valve at a supply, an exhaust. Then you have the isolation room. So you have an NT room also over here. So we have venturi valve to control here, the supply here, and the exhaust over here, right? And here, that's where the VAV box, right? It's just a normal consult or waiting room. That's where we typically use the VAV box. We don't use venturi valves over there, right? Then these are fume hood controls, right? Where you have a hazardous chemical that you want to test it, and you can see it's a special coated venturi air valve, right? Again, this is to prevent corrosions. So these are some of the fundamentals. So we have full suites of solution, especially when we are looking at controlling the airflow. Let's look at the layout, right? I mean, this is one example, right? We talk about Venturi, then you also have all the sensors that plays a very, very important. I'm going to talk about more of all the other sensors. Again, this is how the typical for fume and how all the installations are done together. Let's talk about controllers and monitoring. Again, this is also I like the subjects quite a lot. I'm from the controls part of it. But again, this is very important, right? You have all the muscles that does all the critical, but that's where the controls and monitors comes to make sure that, everything is under control, right? And you can monitor and control it. So the first one I was talking about is like, of course, Triatek, when we bought it, was like a standalone company. They also have a standalone solution, basically FMS. This is basically a controller with the display, right? And you see the lights over there? It's a patented 360. Basically, when you install it, people from sideways can see. So the nurses can see, the surgeons can see actually the environmental control of the operation room itself. Is it okay if your CO2 level is high, if your humidity is high? These are some of the fundamentals that are critical for environmental controls, right? So you look at over here, right? It shows the temperature, it has CFM, number of air exchange, and even the ppm. Right? So you have alarm, which is audible, and you have another display that shows that multiple, right? Multiple. You can have up to 6 displays in a room, and this connects to the Venturi valve. So this is basically the controller where you put in all the sensors, the temperature, the CO2 sensors, differential pressure, all goes in, and you have a nice display, which is a halo display. Again, this is another view, right? Again, this is a patented, right? Safety halo is patented by Johnson Controls, right? So you can see it's all at the side. Orange, you'll see not only over here, but then you can see all the sides. So it's visible, even in dark or even in daylight, right? It's quite visible. So we have displays room pressure, humidity, temperature, alarm status, date and time, right? And can control up to 4 spaces. That's the nice thing about this, right? Again, it's backnet, so you have you want to do any retrofit, something that you can look at it, so you can change it, and you put it, and you can connect to any third-party products as well. Again, this is more of a central, especially this is for nurse rooms or certain places where you want to look at all the different rooms. So you can see that anti-room isolation. So you can have one view of how the pressure is, how the temperature. So again, this can be modified, right? It's up to customizable, right? So again, it's a halo display over here, which is patented by Johnson Controls. Again, this is another for fume hood. Again, this is for the wet chemistry that we use. Okay, this is another one I'm going to show. We have shown on a standalone. Now I'm going to talk about how Johnson Controls solution comes in, where we have our controllers, right? I'm going to talk about it next class. So these controllers are connected to all the sensors, which kind of helps to maintain the temperature, maintain the flow, and this is all and this connects to the Venturi valve. Again, remember I was telling you the Venturi valve takes the input from the controller itself and controls the CFM pressure and also the environmental. Then is the temperature, right? And we have all the differential pressure. Again, this is again the differential pressure sensors to maintain the pressure sensor within the room and the exterior. So this is the new controller. We just released it last year. Again, it's not a typical controller that you find in the market, right? Because again, this is designed to have a high-speed pit loop, right? Typically used in the building, the pit loop is not that fast, but this is like in milliseconds, right? Much more faster. Again, this is ensure that you maintain the controlled pressure at a very quick time, right? It's less than 2 seconds or 3 seconds. Again, with the VAV boxes or even with the VAV boxes and the normal control, you're not able to do that. So this is something that was released last year, and this is something that's available right now. Again, with our Johnson Controls Metasys products, we have a full suite of solutions. We have seen the controllers, right? Now we have also, as part of the packaging, we have the door sensors. We have the differential pressure. Again, this is very important to maintain that pressure difference, right? And of course the display, right, which is called a C360. There's a different part number for critical environment, which is part of the Johnson Control. And of course we have our controller and our Metasys solution. Again, it's the same, right? It's just a high definition capacitive touchscreen. Nice thing about this is that even you wear gloves, right? Especially, when in the surgery room or OT room, you'll be using your gloves and all this stuff. So this is something that you can scroll through. It's just like a normal, what do you call this? You use your iPhone or something like that. So that's how it works. It's easy to scroll up and down. And you can also control. That means, let's say you want to change the set points, something that you can do. But again, there's a 2-level of password. So there's a password for you to go in and change the display or even the set points. Again, this is another view of it. As I said, it's again same. It's just that it's a Johnson branded. So you have the hello, and you can see that in isolation room 1, you have the pressure, you have the temperature, humidity. So again, this is changeable, right? Even the colors are changeable. It's up to the customers to change that. So it's quite flexible, right? You have alarms. You can even snooze the alarm. Let's say you have an alarm, you want to snooze it, then you can just snooze the alarm. It also tells you the timing. So it's quite a nice, nice display. Again, there's another view of it. Again, you can change the set points, again with the password level, of course. These are different rooms, right? Status. You can see a normal mode, warning mode, alarm mode, neutral mode. Again, these colors all can be changed. Of course, alarm you want to keep it red, but others you want to change a different color, you can change it. This is the last one. I think this is my last slide. So another feature is that especially now with the COVID situation, even for normal buildings, we have purging solutions, right? At night you want to purge the office areas, and so we have the same thing, right? So for, let's say you finish your operation, you want to purge it. So you have, you can just click on it. It automatically purges for next 20-30 minutes. It's automatic. So it's all fully controllable, right? You don't have to go to the BMS with it. It's a standalone. Right, that's it for myself. Any questions you have? Thank you.